Now that you've seen how work queue works in production, let's talk a little bit about the fault tolerance aspects of a system. In fact, that's usually the most interesting question about a distributed system. When things go well, we know what's supposed to happen, but really the question is what happens when jobs fail, when tasks fail, when workers fail, when the power goes out, because those are the things that make distributed programming challenging. So let's look at the big picture again. Let's suppose that we have here a factory whose job is to submit workers into a batch queue. And those workers may sit there for a little bit, and then eventually they run in the cluster. And then over here we have a work queue master. That is communicating with these workers and sending them the tasks that need to run so that they run over here. And also there's some data that gets cached over here at these workers so those tasks can run efficiently. Now there's one other piece that we haven't talked about yet, and that is how do these workers know how to find this master? Turns out there's one other piece I haven't talked with you yet, which is called the catalog. And the catalog is a service used to help pieces discover each other in the network. So the master advertises itself to the catalog and says, here I am, here's my address and port, and here's my name. Let's suppose that it's Sims. And now, whenever these workers want to find where this master is, they have to ask the catalog, where is the master called Sims? And then they connect to it directly. Now, it turns out that this is a great place to advertise all sorts of information about what's going on. So this is also where the work queue master advertises how many tasks are running, how many tasks are idle, and all sorts of other performance information. And so if you ever care to see what's going on, you can just go to the catalog and get that information. And there's also a command that gives it to you, which is called work queue status. Now, let's talk about all the different things that could go wrong, because Murphy's Law applies in a distributed system. First of all, what will happen if one of these workers fails? Now, it could fail for a variety of reasons. One is simply that the batch system could decide it's time to preempt that job, perhaps for a more important user. Another could be maybe that machine crashes because it ran out of memory or there's a bug in the operating system. Maybe the power got pulled on that machine and so the whole thing shuts down. But whatever the reason, it's entirely possible that that worker could crash. Now, the system is designed to handle that. And so the work queue master over here can observe that that worker is crashed because the connection between the two will be broken. Now, when that happens, the work queue master knows what tasks were running on that worker. And so it will remember that task. And if this worker goes away, it will simply put the task right back in the queue. And when it finds another worker available to run, it will send that task over. So perhaps another worker starts up here, the work queue master sees that it's available, and it will send that task over here. So when a worker fails, the tasks, if any, that were running are requeued and executed. And it's important to note from the perspective of the application running it, it never sees that. It's something completely hidden from the application. Now, what else could go wrong here? Well, another possibility is that this master could fail. And again, it could be because the power plug got pulled. Could be somebody sent this master a signal. When that happens, all the workers will notice that this master went away because they will see their connections to the master were disconnected. Now, you might think that we want those workers to hang on for a while, but it turns out we really want everything to be aggressively cleaned up, because the most likely reason for a master failure is that the user wanted the whole thing to stop. So in that case, what happens is that the workers stop executing their tasks, clean up their caches, and then for a short while they will attempt to reconnect to the master. I believe it's 15 minutes by default. And if they are able to connect to the master in that time, then they'll start up again, they'll get their tasks and keep going. But if not, then they will shut down and go away. So if the master fails, then the workers will retry for about 15 minutes and then exit. Now, what else could fail here? In a distributed system, it could be anything that could fail. So it's possible that the factory could fail. Turns out that's not very disruptive because the factory gives its jobs over to the batch queue. If the factory fails for a while, well, the batch queue will keep doing its work and the workers will keep working and everything will keep happening. It's just that if we need any extra workers, none of them will be dispatched. And then when the factory starts up again, it can look at the state of the queue, figure out how many workers it's supposed to have, and make any changes as necessary. Now, that does raise the question, how many workers does a workload actually need? And the question's a bit complicated. I can't answer it in 5 minutes, but the short story is we don't need any more workers than we have tasks running and idle. And what's really convenient here is that the master is advertising to the catalog exactly that number. So what we can do is we can tell the factory to talk to the catalog and ask how many workers should be running. The catalog gives it back a number, and then the factory can go out and adjust the number of workers to correspond to the load imposed by the master. Now, what else can fail? Because in a distributed system, anything can fail. Well, the catalog could fail. That does happen from time to time. Turns out that's not a great disaster because each of these components is capable of operating in the absence of the catalog. If the master tries to send an update to the catalog but it doesn't get there, that's okay. The master will still keep doing its job. If the factory can't communicate with the catalog, that's okay. It'll just use its last known piece of information and keep submitting workers. Eventually, the catalog will restart since it's on a reliable server that always comes back, and those components will be able to connect to it and make their decisions. So as you can see, within the system, it's possible for any single component to fail. When that happens, the other components surrounding it have some basic action that they take in order to recover. But eventually, if they can't recover after some reasonable amount of time, and then they shut down. And that's a really important property to make sure that we don't leave things behind on a system. The other nice property about that is that it allows you to start things in any order. So we're often asked, should I start the master first, or should I start the worker first, or the factories? Turns out it doesn't matter, because whichever one you start first, if it detects that the other one isn't there, it will retry for a while until it figures out, until it either makes a connection or it times out. So that describes the fault tolerance properties of WorkQueue.